In this video, we're going to take Fusion 360 and create an intake scoop using surfacing tools. Hey everyone, this is Matt with Learn Everything About Design, and in this video, we're going to add to our Surface Mastery series by creating an intake scoop using our surfacing tools. Now, in the description of the video, you can download the dataset, which contains an original freeform body for an airplane fuselage, and it creates a secondary surface body that has the geometry that we're looking for. Now, there are a few things that we need to understand, some challenges that we're going to run into, but overall, we want to talk about the process of creating this scoop, which takes the original geometry and it creates a section that dips down into it as well as bumps up and away from it. So to get started, you can go to the description of the video and download the data set, and we're going to get started creating our own version of this. The first thing that I like to do anytime I'm working with a design like this is create a copy of the surface body. When we do copy and paste, we're going to have a copy of that version that we can then begin to split up and hack apart. Now, I've been doing surfacing for quite a long time with different CAD software. And my general workflow is to break up our designs into the smallest possible pieces. So if we have half or quarter symmetry, I would split the design up like that. However, with Fusion 360, there are some challenges with the surfacing tools, and I've mentioned these in previous videos. I used to have an entire series where we were modeling a car with them, but I just wasn't happy with the results. So I want to talk about some of the pain points that we're going to have and some of the things that we need to watch out for when we're creating our own surfacing designs. So for this example, I'm going to go to my surfacing tools and start with my trim tool. And I'm going to use my, in this case, the XY plane, and I'm going to trim away the bottom of the design. This is going to leave just the top. And the reason I do this is because now when we're doing things like trimming or splitting faces, it's not dealing with the top and the bottom of the surface. We're only dealing with the top. Now, as I mentioned, generally, I like to work with symmetry. However, that unfortunately is a problem with Fusion 360 because as we create lofts or patches and use tangency or curvature continuity, I've noticed that there's an inconsistency in those internal surfaces. So for this design, what we're going to do is we're going to work with the entire design, drawing half the sketch and mirroring the sketch rather than mirroring the surfaces. So to get started, we're going to go to our top plane and we're going to start our sketch. I'm going to use a line tool coming from the origin and up, and then I'm going to create a secondary line here, hit escape, and we'll turn this one into construction using X on the keyboard. Now what we're going to do is we are going to create a different version than the one I showed you here. We're going to be making our own version, maybe some slight differences. We're going to try to get the best possible surface out of this. So the first thing that we need to decide or understand is, are we going to use straight lines or are we going to use arcs or splines or something else? It's definitely much easier for us to use straight lines for this example, so that's what I'm going to do. But note that curvature with straight lines is oftentimes tricky. So it might cause problems downstream to use all straight lines and fillets, but we're going to use that as the basis just to kind of speed things along. So I'm going to draw out and to the left and begin creating the shape for my design. I'm going to make this horizontal. I'm going to come up and back over to here. I'm going to hit escape, and then I'm going to make sure that this line is horizontal, making sure that those two are parallel, and then we can begin to manipulate the shape however we need. Now, another interesting thing that we need to think about is the fact that we don't necessarily want to come to a point right here. That's going to cause problems when we try to blend surfaces together and create fillets. So oftentimes what you'll see is that some of these things will be offset inward and outward. Because it can be kind of tricky with our surface, I'm going to turn that off or hide it for now. I'm going to go ahead and create a horizontal line here. This is going to allow us to split the inside section that we're going to be building, the section that goes down into our fuselage. And now, before we get too much further, we want to round these corners off. Now, we can do this with conics. I've talked about conics before. I'm going to do this the simple way with fillets, not the ideal way. I generally would use something a little bit better like a spline or a conic. But again, I'm trying to keep this as simple as possible without complicating it too much beyond the surfacing tools. So once we have those fillets, now we can use our mirror tool. We're going to select all the entities that we want to mirror, and we'll pick our mirror line. And now we've got essentially the outline of our intake or our gauge. So the next thing that we're going to do is we're going to figure out where we want this to end up because we're going to blend everything together. So I'm just going to come over a little bit. I'm going to come in and over horizontally. Then once again, use my fillet, trying to keep these to be roughly concentric. We could go the extra step, making both of these concentric, but it's really not that important at this point, honestly. We're just doing this visually. So as long as it looks okay, that's going to be okay for what I want to do. Once again, we'll just pick our center mirror line. And this is going to represent the section that's going to be bumped up and away from the current surface. This is going to be the section that is down and below. And then we need to sort of build in between these curves. And this is an important step in the process to figure out what you want your design to look like in 2D, whether it's from the side or the top or the front. Having these references is really going to help. So the first thing that I want to do is I want to use this as a split tool to split the face. Now, this is going to get a little bit tricky because of the number of references we have here. So we might need to hold down the Control key and try to select multiples. And you'll notice that it's not allowing us to go across this midline and make that selection. If that's the case, let's turn off Extend Splitting Tool, see if it'll allow us to do it. If not, we should go back to our sketch, pick this line here, and turn that into construction as well. And what that allows us to do is it allows us to carry on the tangency whenever we make those selections. So for example, now we should be able to go around and make all these selections to get the full closed path. So if you find that you're having trouble with making those selections, go back, make adjustments to your sketch, and see if by removing or changing some of the geometry to construction, that can help make those selections. The next thing that I want to do is I want to repeat that, splitting the inside. And this time I want to use these inside curves. And I'm also going to try to carry this over. Let's see if we can make this selection. So this selection here isn't going to work simply just based on the fact of that we don't have that straight line. So I am going to cancel that split tool and I'm going to use these straight lines. And the reason for that is because those straight lines will allow us to come all the way to here. Now, if it happens to cut the entire surface body, that doesn't necessarily mean there's a problem, but you can toggle off Extend. And because they do end at the same vertex on each side, it'll just stop at that point. We're going to repeat this one more time. So modify, split face, split this inside face, and now our splitting tool is going to be these inside sections. Again, you can turn off Extend because all of the sketches intersect at the right places. Now, this gets a little bit interesting, just simply based on the fact that we need to go up from here and down from here, and these are just sort of in between references. So we're going to be using these references when we build things out in 3D, and I'm going to get started by defining the section that is going to bump up from here. So to do that, we're going to create a sketch. It's going to be on our midplane here, and I'm going to use Slice, which will allow us to see through the surface. And because we don't have an edge here, we need to use Create, Project Include, and Intersect. We're going to intersect with that section of our sketch or our surface, and then we'll use our Line tool to come up vertically, and then we'll use a Spline tool to go from this endpoint to this one here. From here, we need to talk about the differences between using tangency and curvature continuity. So we're going to make this one horizontal here. Let's kind of bring it down. And when we talk about these two entities here, the intersection curve as well as our spline, we have the ability to add a G2 or curvature continuity, which is going to add a tangency direction to the handle, but also a weight of that based on the radius of curvature of our surrounding surface. If we just do a tangency, it's only going to pick the direction that the surface is going and not add a weight to it. So if we use curvature, it's potentially going to drive this a bit further forward because this radius right here is going to match the radius as it's coming into that point. That's as much as we can do with Fusion. There's no G3 continuity because it's not really a Class A surfacing tool. So we can use G2, the curvature constraint, or we can use G1, the tangent constraint. G0 would be our coincident constraint, which we have just by simply snapping to those endpoints. So this sketch is going to be used to take this vertical line and we're going to sweep this around this profile. Now, when we use sweep, there are a couple things that we need to be aware of. The sweep tool does not have end conditions. We can't drive it with tangency or curvature continuity. So using a sweep as a surface tool actually produces a really nice surface, but it has to be done very early in your design. Because you can't actually drive it with tangency, you need to make sure that you're careful with when you use it and how you use it. In our case, it's fine simply because the curve that we had was on the midline, basically our mirror or symmetry line for this body, which means that the sweep is going to be going out normal or perpendicular to that sketch plane. And that's perfectly fine because we're on the mirror line. You can see there's no line in the middle of that sweep. So in our case, it works. And again, this is an early on kind of thing, something that we want to do very early in our design. The next thing that we need to do with the sweep is we need to trim it so that it blends smoothly into this front edge. And we're going to do that with a sketch. So again, we're going to do this on the side plane. I'm going to take this and hit P on the keyboard to project. Then we'll use a spline. I'm just keeping everything relatively simple. I'm not spending a lot of time defining these curves. I'm going to use tangency here and tangency at the top. And then we're going to hide the body without scoop just so we show our sweep only. We'll use our trim, select that spline we created, and get rid of the top section of both of those. Hide our sketch, and we'll bring our surface back. So when we do this, essentially what we're doing is we're building out a cage or a control for how we want the shape to be built. So remember, we put that line in the center. We built out this curve here. That's going to help us drive the shape. So at this point, this is where things start to get a little bit tricky for us in defining these surfaces. We have a couple of tools that we can use. We could use patch, we could use loft, and those are really the two main tools that we can use to build these. There are some problems with each of these. Loft can do a relatively good job. For example, if we're just lofting between here and here, and we're using this spline as a guide or an interior rail, that can produce a good result, especially if we start driving these using tangency. But the place where Fusion starts to hang up on this is at these edges. Even if we change these from free edges to align to surface, what ends up happening is as we build out the rest of the surface with this tool, it really starts to hang up. And then the continuity that ends up happening in those corners is just not good surface. So you might also be thinking to yourself, well, why don't we just drive this all the way around? We have 4 sides. We can just carry this all the way around. We'll add another profile. We'll do the same thing over here. It's going to give us some errors until we fill in the rest of it. Then we can use our rails at the end and we can drive the continuity. But you can see we're starting to see some problems. Even though we trimmed that right to the end, it's looking like there is a slight discontinuity here from the trim and our surface. So that's going to cause a problem. Sometimes these minor disconnects or discontinuities can be fixed with a patch tool. In some cases, they can't be fixed, and we might just need to get rid of those rails, and that's perfectly fine. That might be a valid option. However, I also have noticed that as the loft goes around this corner, it has a much harder time controlling that shape. So what we're going to do is we're going to select this face and hit delete. Then we're going to try to use the patch tool using enable chaining. And notice when we enable chaining, it's grabbing the bottom edge because we haven't stitched these together. So let's do a quick stitch, put those and these together. And you'll notice that these green edges are going to represent the essentially the areas where these two surfaces will be connected. Depending on the tolerance and the distance between those points, we might now have a single point and it might be a valid solution for a loft. So let's just give it a try real quick between these two edges. And let's select this. Now you can still see the rail is missing a point. If we zoom in really far, we might be able to grab it. But again, these are the sort of problems that we're going to run into. So let's try to use a patch And on the patch, we don't want to group the edges together. We do want to use an interior rail. And you'll notice when we do this, it automatically grabs the entire closed profile. It doesn't allow us to just grab that upper section, which is obviously problematic because we only want that upper section. So we need to kind of move the mouse around and see if it'll allow us to grab it. In this case, it doesn't, but that's probably okay because we're driving this based on curvature. However, we need to figure out which edges we can use tangency on. So as we move our way around, you can see each one is being shown on screen. Edge 3 will be connected, edge 4 will be connected, edge 5 connected, 6 connected, 7, 8. Once we get back around to 9, now we can drive this with tangency. 10, tangency. 11 is going to have tangency. 12, tangency. And 13, tangency. So you can see we got a fairly smooth result. It's relatively close to our to the spline we created. The main difference is that our spline had a direction. So in this case, it actually had a horizontal direction. If that is a critical feature in your design, then we really just need to go back and recreate that sketch where this vertical edge here is either non-existent or its construction. Because it is kind of important to the design intent, I'm going to hit cancel. I'm going to create a new sketch. And I am just going to project that into my current sketch. So just P on the keyboard, and then I can hide that original, finish the sketch, and I can repeat this process using patch. Now when we use this as our interior rail, it's the only one we can select. We're going to ungroup the edges, and we're going to move our way around, making each of these tangent, except for those interior ones, so edge 3, edge 4, let's just go down until we find edge 9, 10. Another thing to note is by default, when we're using patch, the edge weighting when we use tangent or curvature continuity is going to be set to 0.5, where the default for a loft is going to be set to 1. You can change that. It does get a little tricky when you're using patches, but you can change that. So overall, this looks okay. I can see a little bit of weird shading that's happening right in the middle. That could potentially cause a problem. You can see there is a vertex here. And part of the reason that vertex is there is because we had a sketch right there. Now, the surface itself doesn't have any splits in it, but that edge right there is introducing some problems into the surface. If we double click on this patch and we clear that midline and we say okay, it's a much smoother result because we're no longer using that to drive the curvature. So that's an important thing that we need to consider. Sometimes we need to make these choices or decisions based on the geometry that we're using. So in this case, I'm going to not use that guide, and I'm just going to allow it to sort of taper down a little bit instead of being horizontal there. Because I think that the continuity or the surface quality of the rest of this is much more important than having that little design element. The next thing that we need to do is we need to build the surface that's going down from here. So I'm going to delete that. And then I want to use my ruled surface tool. So we're going to come down and find ruled. I'm going to select these inside edges. And I'm going to have this go to a direction. Now the direction is going to be my top plane. And that will allow me to build these surfaces downward. So I'm going to add more edges. And part of the reason I'm doing this is because I want this edge to go down to here. So we're going to say, okay, I want that edge to go down to give me a place for this to sort of live. Now I know that at this corner or this point here, that we're going to end up trimming it back, but we need to figure out a way to blend everything together and get down to that point. So I'm using these edges that we created by splitting things up, using tools like ruled or extend, and allowing us to build out our 3D references relatively easily. Now, part of the reason we did that is because this edge and this edge are offsets of each other, which means that they're nice and consistent width. If we were just to manually push it down, it would likely be flat. And you can see that these match the shape of the rest of the chassis or the fuselage. So let's do another sketch from the side. Let's use slice in our sketch. And we're going to project this inside face, so P on the keyboard. And then I also want to use create, actually, you know what? Let's just create a spline here and let's see how this looks. So we'll go from up here to down here. We'll add tangency at the top and tangency at the bottom. And we'll finish the sketch. So what we're going to be doing with that is trimming. Once more, we're going to select that as our trim tool. We'll rotate it around to the bottom, get rid of that little piece, bring this back down, get rid of that little piece, and we'll say OK. So this is going to be essentially a sacrificial surface. It's just temporary because we don't actually need this one here. We can delete that and get rid of it. Because of the split, we're automatically going to have a little bit of an edge there. But what we want to do is we want to build from here down into here. And we can do that with the patch tool. We don't want to use enable chaining. We want to manually select these edges, and if it'll let us, and work our way around to the bottom. And then edge 4, we're going to have tangency. And then all the rest of the edges, we're going to just allow it to connect. So this surface, we don't need anymore, but this is essentially where we're going down to. And then we're going to fill in the gaps between these. So I'm going to stitch these together for now. Now, you will notice that this is green for some reason. I don't know why. Let's see what happens when I hit OK. Looks OK. Those are all connected. That is another surface piece. I do need to include that in my stitch. We should have a single surface body. So now we can try to use our patch tool. I'm going to enable chaining again, and I'm going to group all the edges together. I'm going to see if I can drive this with tangency. It's probably going to fail, but it actually doesn't look too bad. I don't really like what's going on here at this corner, but overall it doesn't look horrible. But I'm not really sold on it either. So I'm going to do connected. I'm going to say OK. And part of the reason I'm doing connected is because that'll give me a nice, good quality surface, and then I can blend things after the fact. So part of the reason we're having trouble is because everything is coming down to a point over here, and that point is essentially just causing us problems. Another thing that we could do is we can get rid of these faces. I know we stitched them together, but we could get rid of those. And actually, you know what? Control Z. Let's undo that. Here's what we're going to do. We are going to turn off enable chaining. We're going to work our way around this design. We're going to select these small pieces, but we want to go over the top of this. Now, part of the reason we want to go over the top of this is because we'll be able to drive the tangency at the top. Let's see if this works. Cross our fingers. All right, so these ones at the top are going the wrong direction, so that's not actually going to work for us. So we have to ungroup the edges, and we need to find those edges. So let's find the edges at the top. I think edge 4 is at the bottom. Let's see, edge 5, 6, 7, 8, 9. And we want to switch the direction on that one. So just basically pull that edge down. So this dialog box, let's see if we can get this a little bit bigger. Let's try minus 0.5. It does not like that. I'm going to make this one connected for now. I'm going to make the next one connected. And just working around. Let's see, this one here will be connected as well. So we're driving tangency off of, let's see, edge 7 is at the front. And everything else looks pretty good. Let's go down here. That one's okay. So I'm going to say okay to that. I think that looks okay. Now we need to hide that, and we need to delete or get rid of all these extra faces in here. We don't want to leave those in there. Just hit delete. And now what we're left with is that nice smooth transition. It's a bit sharper on the outside I'm going to go ahead and stitch those together. And that gives us a pretty decent result. I'm going to try, which probably won't work, but I'm going to try to fillet this. Yeah, I didn't think that was going to work. Okay. So one of the ways that we can blend this together now is, again, another sketch. We're going to go to the top. And keep in mind that we are doing this essentially together. This is different than the one I created for the data set. So we're exploring these options and figuring out what works and what doesn't. So what I have here, God, that is horrible. Let's drag that back. So what I have here is a projected edge. Then I'm going to take that and I'm going to offset it. I'll go 1 millimeter and we'll offset, well, why does that? We're going to offset that one the other direction. And because this down here was horizontal, these vertices will be on that edge, so that'll be fine. And we can use these as trim tools or split tools. So we're going to do a split face, and this is going to be our tool. And we'll bring that sketch back. We'll repeat it. We're going to split the inside now. We'll use the inside offset. And now what we're going to do is we can get rid of those faces. Just select them and delete them. Now, theoretically, if this works, we'll enable chaining. We will group all the edges. And we'll make them tangent. So what should happen, theoretically, and we'll have to zoom in a little bit, is at the top, we should be smoothly blending down to this edge. If we rotate it around to the side, should be true here as well. Should be smoothly blending down between those. So we'll say OK. We'll stitch them together. And now the end result is somewhat smooth. Control 4, hide the edges, and that looks pretty good. So the main reason that we had to jump through so many hoops was to make sure that the transitions between all these surfaces were good. And the final test of this is for us to take a look at our curvature map analysis and our zebra stripes. Now, I'm going to turn on high quality. I'm going to drag this down. And what we want to see is that the transition in curvature doesn't have any major discontinuities like it does here. Now that to me is not great. However, the consistency around the outside where we have the larger transitions and surfaces, those are quite a bit better. This area down here, I don't really like what's going on there, but I am going to take this one as a win. I also want to take a look at the principal max. I'm going to reduce this down to, let's say, 3 millimeters. Let's go to 3. Now what I'm seeing here is that the fillet or the radius in those corners are fairly consistent all the way around, and it's fairly consistent down here. If I go up to, let's say 4, they're starting to come into those corners. 5, we're starting to see it connected. If I go down to 2, then I'm just seeing it on that upper edge here. So I'm pretty happy with those results. I think that looks pretty good. So again, I'm going to take that as a win. I think that's a pretty good result. In the analysis folder, I also want to go in and take a look at my zebra stripes, which might be a bad idea, but let's go ahead and just take a look. So when I take a look at the zebra stripes, what I want to see is I want to see the transitions to be relatively smooth. And in the corners, you can see there's a little bit of a jump right there between black and white. And we saw that when we were looking at the curvature map analysis. It's an area of concern. This stuff up here, where it starts to drift to the side and come back, we also saw some curvature anomalies in there. We can see those as those sort of jumps or discontinuities in those lines. So if we compare that to, let's say, curvature map analysis on the Gaussian, you can see right there how there's this sort of color jump that's happening. Now, if we switch between that and the zebra stripe, we can see that as well in the zebra stripe. And these are generally things that we would want to avoid. We don't really want to have those. But the surface quality here is probably as good as we're going to get with something like this. So I know that was a 30-minute roundabout way to get to this end result, but I think overall, when you start working with surface tools in Fusion 360, you're going to have to find some of these workarounds. At least currently, the surface tools are they have a tendency to produce some less than ideal results in some cases. So make sure that you do check things like the zebra stripes and the curvature map analysis, and also just rotate these things around. Take a look at them in the render workspace and just see if you can identify any potential problems just by looking at the way that the lighting and the shadows are hitting your design. It can be a really good indication that you have a good set of surfaces or you potentially have something that you need to address. Overall, I'm pretty happy with this. If you have any questions on this, please let me know. As always, thanks for watching, and we'll see you in the next one.